Until now, we have completed around 4 steps in this project. The first step was starting with the problem statement, understanding the objective. The second step was loading the data. The third step was data transformation. The fourth step was creating a data model and creating few measures, columns that will be helpful later on. Now let us get started with univariate analysis. Univariate is one variable at a time. Within univariate analysis, there are two types of analysis that we are going to do. If the variable is of the type categorical or discrete, these two type of variables, we will have one type of treatment. If the variable is continuous, if it is of the third type, then we explore them slightly differently. Let us see that process. In fact, we haven't yet started any data visualization or dashboards or anything. We are still exploring the data. Our objective is not to create a beautiful visualization or an attractive dashboard at the end of it. Our objective is to solve a problem. Our objective is here to find out what are the factors that will influence the stroke. That is our objective. Always keep our objective in mind. And I'm assuming that when you're watching this video, you're pausing and you're doing all the tasks and exercises as I am moving forward. If it is going too fast, stop it in between, recap it multiple times, replay it multiple times, and then complete it. As we can see, there are some issues. We are going to solve them later. I can see some blanks are there somewhere. We are going to resolve them a little later. Okay. Maybe in this step, we will resolve them. So let us get started with exploring the categorical variables. To explore the categorical variables, you have to create frequency table. What is a frequency table? You simply take a categorical variable, find out the count in each category, how many male are there, how many female are there. Or if you are talking about smoking status, how many people smoke, how many people do not smoke. Simply create a frequency table. So let us take these categorical variables one by one. So the first variable, since we have anyway formatted these tables, I will take one formatted table here. I will paste it here. And there is another standard formatting that you can do. If you click on the table and then if you go to this option, format visual, style presets are there. You can take any of the style presets, bold, header, flashy rows or contrasting alternative rows. This you can take, or you can take flashy rows, any other one, or any bold header or something like that. So generally I take contrasting rows, bold header not required, default is this one. Okay. And let me take contrasting alternating rows. Is that better? Or sparse? That is also not bad. Okay. Now from here, I'll remove stroke rate. What I'll do, high risk age, low risk age. This is not the age I want to take. Marital status. I'm exploring marital status. Some people are married, some people are not married, some people are NA. Now, how do you get the count? Count is easy. Take the ID, put it here. Now it is giving like this. What we need to do is we need to summarize this. Sum or average or minimum of the count, count distinct or count. In our case, ID is distinct anyway. This is the one. That is how you explore this variable. What is the variable name? Marital status. Okay. Let me copy paste this. This is easier. Copy paste this. Control C, Control V. After that, ever married. Next variable is gender. Control Z and let me do Control Y, Control Z. Now, instead of, let me do one more Control Z because I have to keep the count of IDs as well. Okay. So, ever married, count of IDs. I will remove ever married and then I will bring gender here. Gender is, even if you put this tick mark, that will also work, but I'll take gender to the first column, count of ID to the second column. Gender, female are, how many female are there, how many male are there, that you can check. Basically, we are exploring categorical variables. If you find any interesting pattern, sometimes if there are any missing values, NA values, that we will get to see here. Okay. That will help us in doing further cleaning. because while we are doing the data transformation, we could see only few rows. We cannot get the complete idea about the full data. You have to explore each and every variable by variable, then only you will get an idea. That's why I'm asking you to go through each and every variable. So here, the third one is, instead of gender in this, I will use residence type. That is it. And then the next one is, which one is the next one? Instead of residence type, I will use work type cleaned. Look at this, work type has 6 null values. We will now go back and clean this variable. Let me complete the rest of the columns, then we will clean this work type. Make a note of this. Work type cleaned has null values that need to be cleaned. Maybe we can put it as NA or the other. Okay. Work type cleaned. As of now, it has blank values, 6 of them. And then Control C, Control V after work type. Since it is a related table, we don't need to worry about rechanging the count of ID or anything. You can directly take smoking status. That's the only variable that is categorical. Again, smoking status has some null values. What we can do is we can put them under unknown. Unknown and null can be treated the same way. Okay. So 1, 2, 3, 4, 5 need to be created. In fact, high risk factor, low risk factor also there. Let us create quickly for them as well. High risk type 1, type 2. So here I will take risk factor 1. Again, put it as the first column, risk factor 1. A lot of people have low risk. That is good. And then risk factor 2. Once again, you don't worry about the formatting right now. We haven't yet reached the play phase where we are really doing any visualizations. We are not doing any visualizations as of now. We are just, our effort here is to mainly focus on the data exploration. We are exploring all the categorical variables. Okay. We're exploring the categorical variables. A good idea would be to, like, let us rename this. Let us rename this as categorical variables exploration. Okay, that is the one. A good idea would be to add percentage. Sometimes numbers are good. Along with percentage, they look even better. Now to calculate percentages, we need to create a measure here, because you want to find out what is the percentage of this in the overall data, what is the percentage of this, how many, what percent are female, what percent are male. You want to calculate the percentages as well. How do you calculate the percentages? You have to add a new measure. Okay. Let us see how to add that new measure that will give us the percentages. Okay. Let us see that. Here is the new measure. I'll go to all measures, new measure, and then add a new measure, percent of total, percent of total, percent of total, that is equal to, percentage of total is equal to how much? First count the IDs. This is not giving me the drop down. If it is not giving me the drop down, I'll just submit it and it will throw an error. Then it has to give the drop down. Sometimes it is little slow. That's why we have to first submit it, then it will give count, general ID, all those IDs. Where is the general ID? Okay. Divided by, now this is context. If divided by, again, I have to count all the rows, isn't it? I have to count all the rows. This is count in this context and then count all the rows in the full data. That means 1753 divided by 5110. 2985 divided by 5110. So count rows is the function that I have to use. So count rows, there is another function called count rows if you want to count all the rows in a given table. And what is the table name? General details table. That is it. You can mention the column if you'd like to, otherwise that is also fine. Let me mention the column. column is ID, or even without the column is also fine, no problem. Now this particular one must work. Let us see whether it will work or not. Okay. Now let's take one example. Okay. I'll create a new copy of this. Okay. Duplicate page, exploration. Okay. Rename that as exploration cat variables, categorical variables, exploration 2. Yep. Okay. Now what I'll do is I have created this new measure called percent of total. I'll go to this table. Okay. In this, I want to add it. Maybe let me make it a little cleaner here so that you can follow this and understand all of these. Let me put these tables here, here, and this one is here. Okay. Now, if you come here and then put percent of total, if you include that, you can include that by dragging and dropping here. Percent of total, and this percent of total. Right now, this percentage total, you can click on this percent of total and make it like percentage. And if you make it like percentage, this is 100%, 100%, 100%. And this is what you will get, because these formulas are very much context based. If you count rows, only count rows related to this no will be counted. If you count rows, only count rows related to this s will be counted. So numerator and denominator will be same, because everything is, all these formulas are context based. How do you remove the context? There is an option. You can bring that outside the context. If you want to calculate this outside the context, you can use all. All is the one that will remove the context, whatever table that you give. Now what it will do is, apart from this context, everything it will take. Okay. That means it will take all the rows. I have modified this formula. Now it gives perfectly. Check this out. Now you can come here and then add percentage of total here as well. Now here in the numerator, if you go to the percentage of total, in the numerator, everything will be related to context. In the denominator, I have removed the context by mentioning all. By taking all, I'm not just looking at female count of rows. I'm taking all the count of rows, which will be like 5110. Okay. In this context here, total context has 5110 in the numerator, and all also 5110, that is 100%. Okay. So I'll come here and then add it there as well. Percentage of total. Percentage of total. Let me put it as the third one. Percentage of total. Count of ID is second one. Okay. Percentage of total. I think it is looking very, very cluttered over here. Let me remove some of the tables from here and then rearrange them. So let me take this high risk factor. I'll just remove the high risk factor for some time for this discussion. Okay. So let's go to this table. Low risk factor 1 also I'm removing. And then let's go here. And then let's expand this table. You can see that rural 49%, urban is 50%. Then go here, work type, cleaned, percentage of total is what I'm adding. And this is the result that you will get. Check whether you're also getting the same result as I see here or not. Okay. And then never smoked, and smoking also we will do 1%, but it may take a lot of space there. As of now, I'm just deleting this. Okay, you can create all of them maybe in a new table, in a new sheet here. You can create in the new page. Delete that. Percentage of total. So what you need to do when you're doing this univariate analysis is make a note of some of the issues. Here work type cleaned has some blank values. Okay. And what else has some other blank values? Smoking status has blank values. Okay. Now I have to clean these two variables, smoking status as well as work type clean. What about other variables? They look almost good. So make a note of work type clean and smoking status, or let us clean it right away. Okay, before we proceed, smoking status and work type clean. So I'll go to transform data, and then go to our work type. Work type cleaned. I think we could have observed this earlier itself. 6% are empty. Select this, and then what is the option? What is the option? Do you remember? Select this, transform, and then replace values with what? Here, missing values are replaced. There are null values, isn't it? Are there any null values? Let us check that. Are they given as null values or simply space? Let us see. Empty values. Okay. Fill. Okay. Replace values. Value to find is what? What we need to find and what we need to replace that with? We need to find empty value, replace it with what is the other category in work type? Unknown or NA? NA. Replace with NA. Okay. Now check that. Now replaced value, rename that as replaced space in work type. Space in work type. That is the first cleaning that we are doing. And what other issues we had? Rename this work type. Work type. Okay. What other issue we have observed? What was the other variable that we have observed? Is it smoking status? Is it smoking status? Let us check that. Work type is okay. Smoking status. So if you go to smoking status, I think it is in this table. Now if you go here and smoking status, some places there were issues. Here it is not showing, but replace the values. If it is space, you make it as unknown. Okay, already unknown is there. Space values can be replaced with unknown values. Replace the value, rename that as smoking status. Cleaning. At the end, most important thing is close and apply. Once you say close and apply, then only those changes, everything will get updated. Even here, automatically, the blank values that you see here, they will automatically get updated. Blank values are NA values. Smoking status is unknown. Hey, smoking status, why it's not showing it? Let us see what is the issue. Let's go back to the smoking status. Once again, we will go to transform data. Have I made any error? Have you found any issue? Anybody in the risk factor table in the smoking status? Are there any null values still? What did I do? Space values. I have replaced them with unknown. That looks fine, isn't it? So I have given slightly space value, but that should be fine. Let us check once again. Still, it is showing. That means, is it reading it as null values? Let us check. You can also do it along with me. Try to see what is the error that we are making. We have taken this column, that is the smoking status, and we would like to replace values. The value to find, is it by any chance null? I'm just thinking unknown. Okay. Okay. Null by unknown. Is that going to work? So here it was not space, actually it was null value. So when we used in the transformation, when we have used null instead of space, that is when we got to clean that variable. In fact, If you go to that risk factor, maybe this step, smoking status, space is not required. Replace the value in smoking status. Okay, replaced null value, let us say null value in smoking status. You will get to know what is the issue only when you study the data. Within a flash, we will not understand what is the issue, whether it is null or zero or something. Only when we study the data, when you see the variables like this, then you will get to see this load more and all that. Let us suppose if we do not know this, simply delete this, delete this. Let's say we have the issue in smoking status. Then you load more, okay? Then you'll get to know nulls are there, okay? Then we will be writing the command, okay, I have to replace the null value. So what I'll do is I will take this and then try to, so right now everything is selected, load more, all these are there. Now what I'll do, I will replace values, transform, replace values. That's where I'll get to know whether nulls are there or not, or it is missing values or anything. Replace null values with unknown. Unknown is already there. It will be adding up to that unknown. Then you can rename this. Go to home. Like let us also rename this. Only when we do like this, only when we rename everything, then only we will be able to easily understand what steps means what later on. Okay. Close and apply. Formerly spoke, never smoked, unknown and all that. Applying the changes. Okay. Null values are now in part of this. Okay, the same way, every table will get updated everywhere. Okay. Everything will be get updated. Even NAs can be like other can be put in under NA, or we can leave it as it is also, that's fine. Okay. That is the exploration of the categorical variables. What are categorical variables? In a variable, you have some categories. Similarly, we go to the discrete variables. So what is the interpretation of this? Observe the percentages. If you find anything really strikingly different, a lot of people, let's say if you take work type, private work job are almost 50%. That kind of notes you can make. You can say that people who are married in our data set, it is mostly dominated by married people. Two-thirds of the people, 65% of the people are married, only 35% are unmarried. These are some of the notes that we can make apart from whatever we have seen, like either missing values or any of the other issues are there. That also you can make a note of it. Because when you look at the full data, it will be difficult to browse through the full data. Only when we see each variable by variable, we will be identifying more and more issues. So make a note here. When you are doing the univariate analysis, you may have to make a note of all the issues and try to do a little bit more transformations if there are any required. Okay. Then go to the discrete variables. What are discrete variables? Some of the variables that are numerical, but they take only limited values. So let's go here. Let's copy paste a table. Let's rename this page as discrete variable exploration. Discrete variable exploration. And instead of gender, the discrete variable is heart disease. Now it is automatically taking sum of heart disease. You have to say, don't summarize it. Don't find the summation. Now heart disease, it takes 0, 1 and blank. See, you have to do the cleaning here for this discrete variable. We will do that. It's not a problem. And then Control C, Control V. Then what do you do? Instead of heart disease, the second discrete variable is hypertension, whether somebody has BP or not. Instead of taking summation of hypertension, don't summarize it by hypertension. Again, this also has missing values. So what you need to do is you have to take care. Another discrete variable is stroke. How many people have stroke? How many people do not have stroke? We already have that idea on it, but let us do one analysis on stroke as well. Instead of summation of the stroke, don't summarize it. Stroke looks clean. Around 5% have stroke, remaining 95% do not have stroke. The zeros ones are fine. The remaining ones, you have to replace them with NA or some value. So what will you do that replacement, or you want to leave them as it is, that is also fine. Or you can also put them as NAs, or you can put them under something else as well. Okay. So as of now, make a note of these missing values. We will handle them a little later when we do the binary analysis based on some other variable, whether we can do any type of cleaning on this, we can do it later on. As of now, make a note of this, keep it aside. We will come back to this later on. That is a discrete variable. Now go to the continuous variables. Okay. Let's go to the continuous variable exploration. As of now, you make a note of these. Okay, you make a note of these missing values. Earlier we have anyway cleaned them, but as of now you make this note. There is another concept. After discussing that, we will clean these missing values. How do you actually replace the values? Maybe you can put NA, or you can club them with zeros, or you can club them with ones, depending on the situation. Okay. Now, continuous variables. What are the continuous variables? Age is a continuous variable, and average glucose level is a continuous variable, and BMI is a continuous variable. If you want to explore continuous variable, you can use something called distribution charts or histogram. Okay, so you can use this type of chart and then put age over there. Now, instead of creating one chart like this, you have to select this clustered column chart, and there are some more steps that you need to take. Okay, you have to put age on the x-axis. Okay, then what you need to do is you have to put count of ID on the y-axis. You have to put it this way: age on the x-axis, count of ID on the y-axis. Okay, maybe by doing a little bit of formatting in this, it'll look better. But as of now, this solves our purpose. Okay. So how do you do a little bit of formatting? Take this one, and then columns or the data. General formatting, if you go, the effects, the background effect, visual border. I want to make this a little, the color of the background, you can change it. Transparency is also fine. What I'm trying to do is, in this visual, I want to make these bars little thicker. Height and width is fine. Background, visual border. You can take the age variable and then try to go to, when you click on this age variable in this one, and if you go to this whole number, if you make age like a whole number, then what you will see is those decimal values that were there, they will be ignored. Then you will see a chart that will appear like this. This is the histogram, or simply the clustered bar chart. This will tell us what is the distribution of age on the x-axis. You can see, let's say, if you want to increase the size of those labels, data labels, let's say if you want to slightly, like if you can see these values 10, 20, 30, like these are the number of people who are less than age 30, and you can see there are some people who are around age 80 also. There are some people who are having age very, very less also. There is a good number of people. This will give us an idea on the distribution of the age variable. Okay. Now there are another ways of looking at the distribution as well. Maybe you can make a note of this, that okay, in age there are some people who are at higher age. Within age there are some people who are at lower age. That is one way of looking at it. There is one more way as well. You can look at box plot, or you can look at violin plots. The distribution that you have seen here, so the same thing gets into violin plot, but only thing is it is in the vertical format. So let us see, if you want to represent a continuous variables distribution in a much more detailed, or in an attractive way, then you can use box plots and violin plots. Let us see what exactly they tell us, these box plots and violin plots. The box plots and the violin plots, they are not part of these visuals right now. If you see here, These visuals contains tables, map charts, trend charts, or clustered bar charts, but we do not have box plot or violin plot. Those are the extra visuals that we need to extract them. Using this option, get more visuals. Click on get more visuals. Then you will get an option to do the searching. So go here and search for box plot. Once you search for box plot, no results found. Let me just type for box whisker. This is one visual that you may want to add it. There are other visuals as well. You can add this. We'll try this one. Then it'll appear here, extra visual. Can you see that? Import successful. And apart from that, I also want to get violin plot. Both of them tell us the same story. Violin plot, violin. This is the one. You type violin plot, add. You may not need to type everything. You just type box, you will get box, you will get violin. Can you see the box and violin? Then let us create a box plot for age variable. Then I'll tell you how to interpret it. Okay. So click on this box plot. Oops. Let's keep that as it is. Go and click on empty place. Click on that. Then get age variable. Okay. Now we need to be a little careful here while you are creating this box plot. So instead of age directly dragging and dropping on that, just delete that. First, on the access variable, drag the ID, and then on the value variable, drop age. Okay. Then instead of sum of age, you can take average of age or sum of age. Doesn't really have a big difference here. And to make it look a little better, what we will do is we will bring it onto this side. This is called as a box plot. Okay, let me make this a little smaller and let's make this little large. Whatever this particular chart on the left hand side is saying, the same thing is told by box plot, but it will give you a little bit more information. What box plot is going to give you is, it will give you minimum value, the one that you see here. So this is known as minimum value. This is the minimum value of age. Here, minimum value of age is around 1 or 2 years, I think. Okay. The one that you see here, this line indicates, let's say if it is meeting here. Okay. So what does that mean? That is known as 25 percentile value. It is also known as first quartile, 25 percentile value. What does that mean? 25% of the data is below this. Check this, quartile 1 is 25. So 25% of the people are having age below 25. So if you take here and if you come down until this point, 25% of the people have age below 25. Okay, age 22, 23, 24, 25. So if you take this age, 25% of the people are having age. If you take all these, okay, if you take all these, then around 25% of the people are falling there. So basically what it tells us is here 25%, if you have 5,000 people, roughly around 1,200 people have age less than 25. This is 50 percentile value. 50% of the people have age less than 45. That's what this is saying. If you go here again, the median is known as 50 percentile value. This is known as median or quartile 2 or 50 percentile value. 50% of the people have age less than 45. So if you go to age of 45, by here 50% of the population is covered. That is given here. 50 percentile is how much? 50 percentile means median, that is 45. Okay, 45. Here below 45, 50% of the people are there. That means if you have 5,000 people, 2,500 people have age less than 45. This is known as 75 percentile. This is known as 75 percentile. 75% of the people are quartile 3. 75% of the people are having age less than 60. Is that what it is saying? Quartile 3 is 61. That means if you go here until age 61, if you go, 75% of the people are covered below 61 age. So until here, until this bar, 75% of the population is covered. That means by here, 2500 plus 1200, somewhat 1250 or something. That will be 3750 people out of 5000 are having age less than this. Okay. And what is this one? This is the maximum value, whatever is the maximum value of age. What is the maximum value of age? If you put your cursor here, max value of age is 82. 100% of the people, Q4 or 100 percentile. What is 100 percentile? 100% of the people is the maximum value. 100 percentile is maximum. 0 percentile is minimum. 100% of the people have age less than 82. This is box plot. It will tell us what is the distribution of the variable. So here the box plot looks fairly good. Sometimes what happens is if you're taking income, 75% of the people have income less than 60,000, but the maximum income is going until 5 lakhs or let's say 50 lakhs. That means there are some outliers in the data. This box plot will help you to detect outliers. If the box appears like this, that means this is the minimum value, 25 percentile, 50 percentile, and then the third quartile, and then the maximum value. If there is a equal or almost similar distribution like this, then there is not much of outliers. Okay. But if there are outliers, that means by here 75% of the data is covered. If you're taking income, let's say this is income 60,000 or 6,000 is around 75 percentile. 75% of the people are earning less than 6,000. But if you see the maximum value, it is going until 1 lakh. Okay. That means compared to 75% of the people, these people are earning very, very higher amount. That means these are considered as outliers. When there are outliers present in the data, the box seems to be compressed either at the lower side or on the higher side. That's what box plot tells us. If the box plot is like this, if the box is well distributed, that means there are not much of outliers. It's very clear indication that there is not much of outliers. The same thing is given by the violin plot as well. Okay. So the same story is given by violin plot. Either you can draw a box plot or you can draw a violin plot also. Let us try to draw the violin plot. And violin plot, in fact, violin plot contains box plot inside it. Okay. Let us try to draw the violin plot. Okay. The interpretation of the violin plot is same as the box plot. Okay. The sampling is ID, and then here the value, the measure data is the measure data is age. If you draw like this is the violin plot. In fact, the violin plot takes the information like this only. It tries to show even like the width of this violin tells us how many records are taking that particular age, how many people are there. But both of them tell us the same story. You will understand this better if you look at any variable that has outliers in it. When there are outliers, box plot will not look like this. Now this is age variable, right? Similarly, there is one more continuous variable like BMI, okay, or average glucose level. Those are also continuous variables. Let us make a copy of this, duplicate page. Let us recreate all of them, rename this page for BMI or average glucose level. Okay. Now, instead of drawing the box plot for age, if I take average glucose level instead of sum, let me take average. Look at this box plot. When you compare it with age box plot, average glucose level box plot seems to be compressed. So this is 75 percentile. What is a 75 percentile value? Tell me. 75 percentile value, quartile 3 is 114. 75% of the people have average glucose level less than 114. But what is the maximum value? Tell me what is the maximum value? The maximum value is going until almost how much? Maximum value is 271. Okay. Let us also update the violin plot of this one. Average glucose level. Instead of sum, I have to take average. Average glucose level. The violin plot also looks different, isn't it? There is a lot of data which is here apart from the rest of the distribution. Even this one, instead of age, if I take average glucose level, it looks like that. If I want to change that, you can change it, but average glucose level, most of the data is here. So basically the overall graph looks like this. Most of the data is here, which is less than 114 or something. Most of the data, 75% of the people are lying here. Remaining 25% are going here, and there are some values that are going too far. Too far. These are outliers. Too far. There are some points in the data that are very far away from the rest of the data. They are known as outliers. 75% of the data is below this. What is this? This is Q3 or P75, 75 percentile. This is 114. Here it is 114. And there are some values that are going as high as 272. So what I'm saying is 75% of the patients have average glucose level less than 114, but some patients are going as high as 272. That means there are outliers. The same thing. So looking at all these three plots, I can conclude one thing. Yes, there are outliers in average glucose level. There are some outliers. There are some people with unusual average glucose level. Their average glucose levels are very, very high compared to the rest of the data. Maybe this finding will help us in finding out the factors. Are these the patients who are more prone to getting stroke or not? That can be analyzed later on. What are we trying to do here? We're trying to go through each and every variable and trying to understand it as much in depth as possible. This is data exploration that we are doing. Apart from average glucose level, there is one more continuous variable, that is, what is it? BMI. Rename this, rename this page as BMI, BMI analysis. Rename this BMI. All right, BMI, BMI. Okay. Now what I'll do is I'll go here, and instead of average glucose level, I will take BMI here. Not sum of BMI, take average of BMI. And then in this one also, in the place of value, I will take PMI, not sum, average. If I go here, instead of average glucose level, I take BMI, put it here again. So do you see this chart also having outliers? When there are no outliers, then everything will be well spread. Look at the 75th percentile, which is quartile 3, 32. And what is the maximum value? 97. Again, the same story. By looking at the box plot, you should be able to tell if the box plot is well spread like this. If the box is well spread like this, there is not much of outliers. If the box is compressed either on the lower side or upper side, that means there are outliers. Here, if you see quartile 3, 75% of the people are having BMI less than 32. So if you go here, that is level 32. Around 75% of the people are covered here. Or if you go here, if you go to 32, 75% of the people are covered here. Some people remaining 25% are going here, and some of them are going as high as 97. There are some people here. Most of the people are below 32, but some people's BMI is going as high as 97. Yes, there are some outliers in the data. We may have to make a note of this as well. So this is univariate analysis. One by one, one by one, one by one, we looked at all the categorical variables. We made a note of them. If there are any issues, we took a note. We are going to treat them later. We looked at discrete variables. If there are any issues, we took a note of it. If there are some other type of variables, what are they? Continuous variables. We looked at the, either you can look at the histogram, or you can look at the, or you can look at this bar chart, or you can look at the box plot or the violin plot. All of them tell the story, same story. What is it? Even violin plot is also saying that everything is below 32, and then remaining are going as high as near to 100. That is univariate analysis. One variable at a time. One variable at a time. Try to do the univariate analysis. Then we'll go to our next step. What is the next step? Bivariate analysis. Every variable versus the target. That is our next step. But before going to bivariate analysis, make sure that you have totally completed this univariate analysis and you are getting the same graphs that I'm getting here. your output should look almost the same as my output.